Week 3, lesson 1. All right, so if you read this example, we're trying to find the angle in radians between two lines that are given. Excuse me. And notice that the angle has to be in radians, and it has to be acute. All right, so first thing I want you to recognize is that for line number 1, I have a direction vector. It is 5, 2. And for line 2, I also have a direction vector. It is negative 3, 4. All right, that's because these lines are given in Cartesian form, and the denominators tell you that the direction that the line is going in both the x and the y direction. All right, and then back in week, I don't even know if it was week 1 or week 2, you had a formula for the dot product. So let me write that formula up because it's the one that can tell you the angle between vectors. So we're just going to go ahead and use that here. All right, so when I do a dot b, I have negative 15 plus 8. When I do the magnitude of A, I get, 25 plus 4. And the magnitude of B is 9 plus 16 times the cosine of theta. So let's see, this is negative 7 equal to 5 rad 29 cosine of theta. And if I do cosine theta and I, again, isolate it, I get this, and this is where you have to break out your calculator, make sure that it is in radians, and type it in, and you should get a decimal, right, of 1.83. Okay, now it's a great angle, it's nice. However, it's not acute. All right, acute angles are between 0 and 90 degrees, all right? In radians, that means you're between 0 and pi over 2. So if you break out your calculator and you do pi divided by 2, that means we're somewhere between 0 and 1.57, all right? So clearly this is more than that. So what you have to do is you have to find the reference angle. So if you do pi minus the angle you just got, so pi, I have my calculator right here, minus 1.83, I believe gives you approximately 1.31. Example number 2 that we're looking at right here is also in 2 dimensions. The third one will be in 3 dimensions, but it's really not that big of a deal. You will need a direction vector for line 1. You'll need a direction vector for line 2, and you'll need this formula. All right, so let's do the dot product, which would be negative 2 plus 2. The magnitude of A is, let's see, rad 5. Same thing with rad B. Sorry, that should be a 5. Give me a sec. Let me find an eraser. There we go. That's a 5. Cosine of theta. And when I simplify this, I get 0. Right? This becomes 0, and when I divide by this, it's still 0, which means that this angle is pi over 2, or 90 degrees, which I know is not considered, theoretically, it's not acute. It's actually right, but there's no way to make that into an acute angle. All right, and then this last one, mostly what I want you to notice about line number 2 is that this is in the wrong form. Right? This is not Cartesian form, and the formula is not going to work unless you change this middle term to be y minus 5 over negative 1. All right, so now that that's in the right form, let's get a direction vector for line 1 and a direction vector for line 2, and then let's apply the formula. So the dot product, 6 minus 4 minus 24, equal to the magnitude of A, which is 9 plus 16 plus 144, times the magnitude of B, 4 plus 1 plus 4, times the cosine of theta. All right, so again, you have calculators out. So if you simplify all of that, you end up with negative 22 over 39. And when you put second cosine of that into your calculator, you get 2.17 something, all right, which is obtuse, right? If you think about from 0 to 90 degrees to 180 degrees, right? Anything in this range is acute, and this is about 1.5. And anything from here to here, keep in mind 180 is the same as pi, that's about 3.14. So this is somewhere within this range. So it's obtuse. I need it to be acute. All right, so if you remember anything at all about reference angles from last year, reference angles, you're going to have to do pi minus theta to get the acute angle. Now, what I want you to do in your calculator, do not round this, all right? I need that in your screen, do pi minus the answer and round that answer. All right, again, 3 significant digits would be 0.971. If you use what I have written here, I'm guessing you don't get the same answer. It might round just slightly different. Also, again, important, in your calculator, don't type in 3.14. Use the pi button. It's much more accurate.